All right, so I'm going to break those into its x and y, right? Step one for adding vectors is to break them each into their x and their y. So I would call this side v1x, and I would call this side v1y. I call them 1 because they're both components of the first vector, right? That's really why I'm doing that. So for x here, am I going to use sine or cosine? Because is x opposite or adjacent? It's opposite, so I'm going to use sine. So for v1x, I will use 30 times sine of 26. And so that gives me 13.15. v1y, I'll take 30 times cosine of 26. That gives me 27. I'm just going to round that one up to a whole number. Okay, what's the thing I need to kind of check for after I get to that point? I need to see, do any of my components need to be negative, right? And in this case, what do you think? Do either of those components need to be negative? No. All right, so let's move on to V2. What would cause one of my components to need to be negative? Why would I have to write a negative on one of my components? Yep, if it's south or if it's west. So this one says 65 kilometers west. And again, I'm not drawing these to scale, right? I'm just kind of drawing them. But what would I call V2x and V2y in this case? Do I need to do any sine or cosine for this vector? No. So what would V2x be equal to? Negative 65, right? Because it's going to the west. And so what does that mean V2y is going to be equal to? 0, right? This vector has no part of it that is going in the vertical direction. Okay, last vector here is vector 3. It's 14 kilometers south of west. So I'm going to draw my vector here to the southwest, and then I'll complete my triangle so that my angle sits south of west. So I would call this V3x and V3y. Okay, for x here, what am I going to use, sine or cosine? This time I'll use cosine for x. So it's not like a rule we get to memorize that x is always cosine and y is always sine. That's not true, right? We have to pay attention to the triangle. X is adjacent, which means we will use the cosine. And so for y, we would use sine. Do either of those components need to be negative? Which ones? Or which one? Both. You're right, both. Okay, so we're going to make sure we include a negative there and a negative there because we're going west and south. And so when I add them together, I'm going to give them a name, and I like to call them VRX and VRY. Do you remember what the R stands for? Resultant. Good. So I'm going to add my X's together. 13.15 minus 65 minus 10.4. And that gives me negative 62.25. And so since it's negative x, what direction does that kind of mean that I'm going to be going? West. So I like to draw a little arrow there just to kind of remind myself about that direction. Right? That's not a must do, but I think it's helpful. And then for our y components, we're going to go ahead and add those as well. My y components are positive 27 minus 9.37. That gives me a positive 17.63. And so that would tell me that's going to go upward, right? A positive y value would tell me we're going north there. So tell me, do we have any questions so far about just the breaking down of the vectors, the adding that we did? Okay, so last step, right, is to build our new triangle. So it doesn't matter if you go to the x direction first or the y direction first. But again, I always like to do x. we go 62.25 west and then 17.63 north. My resultant vector here always goes from the origin to the tip of the last vector. Okay, so how would I solve for this side of my triangle? What do I use to help me solve for that? If I have both sides, but I need the hypotenuse. Pythagorean theorem. You could use tangent, but you don't know your angle. So I use tangent to help find my angle, but I'm going to use Pythagorean theorem to find that side. Now, do I need to include the negative there when I put in my west component? No, the negative just tells us what direction to draw it. If we put in the negative, it's going to throw off our algebra just a little bit if we're not really careful. Okay, so I'm going to recommend that you don't put that in. All right, so for the hypotenuse there, I got 64.7. And what would my units be? My original units were all kilometers, so that means my resultant vector would be kilometers. And then we have to include the angle. So here for the angle, I would go second tangent of opposite divided by adjacent. Okay, so opposite over adjacent, 17.63 divided by 62.25. That gives me 15.8 degrees. 15.8 degrees. And then what of what? What are you going to be? South of east, west of north, east of south. North of west, right? North of west. You're going to decide what axes is it touching, right? North, east, south, or west. Well, my angle is touching the west axis. And then I decide, does my triangle swing north of west or south of west, right? My triangle swings north of west. So this is a full and complete answer. It has to have both the magnitude and the direction, right? It has to have both of those things. Next type of problem we're going to look at is a rolling projectile. Okay, we're going to say a marble leaves the table, just like the lab we did. A marble leaves the table at a velocity of 3.21 meters per second. If the table is 1.16 meters high, how far away will it hit the floor? But let's go ahead and analyze what we do have. A marble leaves the table. So here's my table. Here's my marble. Right? It's going to fall and hit the ground somewhere over here. This velocity that's given to us right here, do we need to break that down? Or what velocity is it? Do we have an angle that we can use to break it down? No. So it's got to either be Vxi or Vyi. So which is it? Vxi, right? The second it leaves the table, it's still moving horizontally. And so what does that mean for Vyi? It's 0, right? For a rolling projectile, we always know that Vyi is equal to 0, right? The second it leaves the table, it is moving only horizontally. Okay? The table is 1.16 meters high, right? 1.16 meters. And so what variable does that give us? Y final. And is our Y final going to be positive 1.16 or negative 1.16? Negative 1.16, because here's my origin, right? My origin is at the end of the table. And so if my object lands right there, my X will be positive, but my Y will be negative, right? If we just think about it on a coordinate system, my X is going to be positive, but my Y is going to be negative. So That's what we're looking for there. My overall question is how far away will it hit the floor, which means I'm looking for this distance. So what variable does that mean? X final, right? So that means X final is my main question mark. So I want you to take a look at your X final equation and find out, can we solve for X final with the information that we have? I have to find time. Look at my X final equation. Vxi times t. So that means I'm going to have to solve for time first, right? With a rolling projectile, what equation do we usually use to find time? The second vertical, right? So I'm going to use that equation, y final equals y initial, which we always know is 0, plus vyi t, which we know is 0, plus 1/2 a t squared. That's what I had for my time. I don't know if yours was something close to that or not. Then I can go ahead and solve for X final by taking 3.21 times 0.487. And that gives me 1.562 meters. And this is going to be a launched projectile. Okay. We'll stick with a marble. A marble is launched. I'm going to kind of abbreviate my problem here. Marble is launched 11 meters per second at 38 degrees. I'm just going to say how far and how high does it go? All right, a marble's launched 11 meters per second at 38 degrees. How far and how high does it go? Now, when it doesn't give us, for these launched projectiles, if it doesn't give us direction, we automatically assume our angle looks just like that, right? North of east, or from the horizontal, right? If it says from the horizontal, that means we're going to start at the horizontal x-axis and go up 38 degrees. Okay, and where does that 11 meters per second go on my triangle? It's got to be the hypotenuse. Yep. All right. So if this is my initial velocity, this side has to be Vyi, and this side has to be Vxi, right? It's the x and y components of my initial velocity. So that has to be step one in a launched projectile, is that we break down that vector into its x and its y components. So for x, we will use which one, sine or cosine? Cosine. So 11 cosine 38, that gives me 8.67 meters per second. And for y, we will use sine 6.77 meters per second. Okay, so anywhere in my problem, will I use that 11 again? No, right? So I think 11 and that 38, we're done with that. Okay? It asks me how far and how high does it go. So those variables would be y final, right? And this is at peak height. And then it would also be x final, right? Those are the two questions I would have to ask myself. At peak height, and then my x final. So I think y final is the simplest one to solve for first, because what do we know? If my projectile follows that path, what do I know about it here?
It's going to be the same. It's going to be the same like point where it was launched from.
Yep, it's going to be symmetrical, but my VYF is going to be 0, right? At that point, it stops rising, right? It comes to a stop vertically. So at that point, we can use this information to help me solve for how high it is at that point. I would use my third equation, right? You're eventually going to need time, but I would just go ahead and use my third equation there, okay? So my third equation would be VF squared equals VYI squared plus 2AY final. Again, there's a couple different ways you could get to solve for YF. You don't have to try to memorize this exact path, but it's an option. So I want to make sure everybody's getting that to come out okay. Okay, this is what your equation look like? Wait, are you talking about for x final? For y final, okay. So from there, if we want to solve for x final, we're going to have time. We have to have time. And do I want the total time or do I only want the half time? I'm going to eventually want the total time. But what I can do here, since it's symmetrical, I can solve for the time it takes to reach peak height. Then I can multiply that by 2, right? So I would take VYF equals VYI plus A times T. And that would be to get me to halfway, right? That would get me to the halfway point. That T gives me 0.691 seconds. But that's only the time it takes to go up. So I have to multiply that by 2 to get my total time, 1.38 seconds. Then I can go use my x final equation to solve for my total horizontal distance.